Today, I want to share a mental map that summarizes everything we have learned so far in our web development journey. Think of it as a landscape with three major layers: the front end, the back end, and the database, all connected by the flow of data. Let's begin with the foundation of the web: HTML, CSS, and JavaScript. First is the HTML, the structural blueprint of every web page. It's defined what elements exist: headering, paragraph, sections, buttons, images, and so on. And we learn about the attributes like IDs and classes, semantic tags such as section and meta, and the box model that determined how every single element sits inside a page. And CSS give life and personality to our structures, such as classes, parent-child selectors, which allowed us to target any element precisely. And we also learned the CSS framework, such as Bootstrap, which help us speed up the styling process while keeping up our code clean and modular. Then we learned the JavaScript. It's the engine of the interactivity. Like we learned some modern CS6 features like arrow functions, let and const modules, and higher order functions, which make JavaScript much more powerful and expressive. We also learn about asynchronizations, asynchronous programming with promises, and async and await, which allows our page to fetch data without freezing the browsers. Together, these three form the front-end layer. And if the front-end is face, the back-end is the brand. We explore how the Node.js and Express allow us to create servers that listen to incoming requests. We wrote quests with methods like apple.get and apple.post. We process data from the client and send back JSON response. This is where HTTP methods, get, post, put, and delete become essential tools to our design. Behind the backend, we enter the database. We store and retrieve long-term data. We learn how MongoDB uses a JSON-like structure, making it incredibly natural to use alongside JavaScript. We interact with MongoDB through shells like Mongoose, ORMs like Mongoose, or the native Node.js driver. We explore document queries, projections, sorting, limiting, and even advanced operations like aggregation pipelines and joins with lookup. Finally, we combine all three layers into a full-stack architecture: the client tier, the logic tier, and the data tier. From button clicks in the browser, to logic processing in the server, to persistent storage in the MongoDB, our applications now form a complete loop. This is a full picture of what we have learned. HTML provides structures, CSS provides styles, JavaScript brings interactions. The backend process logic, and the MongoDB stores data. And here comes part 2. I will give a quick and broad description of all the concepts and how they play together. First one is the CSS, the visual foundation. CSS is often underestimated, but it is absolutely critical. We learn that the selectors let us control specific part of the page. The box model ensures we understand the spacing and the layout. And the cascading rules help us reason about which styles apply. When we combine CSS transform raw HTML into clean, structured, and interactive interface. These styling layers is what user actually experience long before any JavaScript logic kicks in. And the ES6 JavaScript is the modern web brand. ES6 turned JavaScript into a robust modern language. Some of the most important features include arrow functions. It simplified the callback and preserve lexical this. And let and const introduce predictable scoping. And the modules make code reusable and scalable. And then the third part is the front-end and back-end communication. The next critical piece is asynchronous communication, which is the bridge that connects what the user sees to the data that powers the application. The typical process look at this. When the user clicks a button, and the JavaScript sends an HTTP request using fetch. And the backend receives it through Express. The backend queries or updates the database. The backend returns JSON. The frontend updates the DOM visually. This flow is the heartbeat of modern web applications. Then the MongoDB query language, MQL, managing data. MongoDB is a natural fit for JavaScript developers because both use JSON-like structures. With MQL, we can find documents using conditions and feature with operations like GTE, IN, or regex. And we combine logics using AND, OR, and NOT. We use projections to reduce the data size with sort pagination and limit results, and we can perform CRUD operations. And it is the full stack workflow. We put everything together. The HTML creates the structure, the CSS styles interface, and the JavaScript handle interactions. Fetch, send requests, and Express, receive and process them. MongoDB stores and retrieves data, and the server sends data back as JSON. The JavaScript updates the UI dynamically. Part 3, I need to deep dive into one concept. I will deep dive to the MQL. For my deep dive concept, I choose MongoDB query language because it truly stands at the core of how data flows through a web application. And what does MQL special? Unlike SQL, which use table relationship and rigid schemas, MongoDB stores documents, which are essentially JavaScript objects. This means you can store nested object arrays and structures that feel natural to work with. Second one is the core query operations. First is the basic queries, the DB user find exact match, and the nested object matching. And we can use also the comparison operators to write highly expressive queries. And the projections helps reduce unnecessary data transfer, which keeps response lightweighted and optimized. Then we can do sorting, limiting, and pagination. We can do the CIOD operations to insert, update, and delete operations remain intuitive because everything is object-based. And the aggregation pipeline, the Power 2, the MongoDB's superpower, lets us perform complex data analytics. We can do match for filtering, group for statistics, sort for ordering, add fields for compute values, lookup for join collections. Then the data relationship with lookup. MongoDB may be non-relational, but it still supports relationships. This allowed us to build real-world applications such as e-commerce, social apps, or analytics dashboards. And the performance considerations like use index to allow MongoDB to respond quickly at scale. Without index, MongoDB must scan all documents, slow and inefficient. Why MongoDB matters? That because MongoDB QL, MQL is powerful because it aligns perfectly with JavaScript and it handles complex data structure naturally. It scales horizontally for large applications and enables fast development with flexible schemas and supports analytical process directly in the database. When I understand MQL, which gives me the ability to build efficient modern web applications that handle real-world data gracefully. Then I will give you a live coding demonstration, like the ones I do, like the teacher do in the class. First one is the box model. Let me create a box model demonstration. Like we specify a box model using the specify the white and height. Order 5 solid green. Specify the body background. Specify the body. And the body says I am Bob. Then if we paste it into a live coding demo, it will show us a box model. And I will show how we can do the HTTP request. Like we fetch something from the internet, fetch some articles, and use the arrow function. Do some arrow action. If we detect some error, then we just throw it. And we return the response JSON. And fetch the data. Bring it to the console. And catch something. Print something to the console. And we fetch the data use the post method again. The same URL, using the same URL. We do the post methods. Post some content tag the application JSON. Fetch the body JSON string by the title, my article, and the content. Just fetch the response. Make it to JSON. And print the data. The console. Once error happens, we also do the error handling. Okay, I think it's the live code part.